Dear students, this is Dr. Week12. In this week, the topics that we need to discuss are linear inequalities in two variables and linear programming graphical method. There are two topics, and the simplest method falls in week 13, so we will see in the next week. For this first part of the video, I will give an introduction to inequalities in two variables, and I attach some links from the popular YouTube videos so that you can easily understand and solve such problems from the PowerPoint. And of course, for the second topic, 7.2 linear programming and graphical approach, I will upload my own videos so that it will be easier for you guys. Okay, let's see some introduction and then look at the description of this video. You can find some links that will give you an idea to solve this kind of problems. Okay, so what is a linear inequality in two variables? That's the definition we start with right now. Linear inequalities in two variables. This is Week12 chapter. So any inequality of this form, a linear inequality in the variables x and y, is an inequality that can be written in any one of these forms given here. You can write 2x plus 3y greater than 0, or this can be a constant as well. 0 can be replaced by another constant. The c can be in the right side, positive or negative, doesn't matter. See, either if you find such an inequality, this is called just inequality, there is no equality. But this kind of inequalities are called strict inequality. Actually, this is inequality. The first one is strict inequality. For example, this one what we have taken is a strict inequality. The term on the left side is strictly greater than the right side, isn't it? But if you write x plus y is less than or equal to 2, this is an inequality. That's all. Greater less than or symbol, less than or equal to symbol, as less than or equal to, isn't it, the symbol. So whenever there is an equality, this just this one equality with the inequality symbol, this is just inequality. But when there is no equality symbol, we call it strict inequality. So there are 4 types, isn't it? So that's it. You can take your own examples to check what is a linear inequality and solving the system kind of linear inequalities. So what the first? Geometrically, the solution of the linear inequality in x and y consists of all points in the xy plane. See, any linear inequality that is given as ax plus by is greater than or equal to 0, you can or a constant, you can say this is a constant. You can say this is a constant c, or instead of greater than or equal to, you can use less than or equal to, or less than or strictly greater than, or anything can be expressed as y is greater than or equal to mx plus c. You will rewrite the function in this form, taking the this negative ax to the right side and dividing by c, dividing by b. So it will be another constant on the right side. Instead of c, you can write here c1, isn't it? So m will be a over b, and c will be c1 will be c over b. Okay, if you express such a form, then we draw the line through the space. This line, we draw the line using the x and c. When you take x equal to 0, you will get y-intercept is c1. Y-intercept in the xy axis, you will find y-intercept is c1, x-intercept. When you take y equal to 0, you will get x-intercept c1 here, isn't it? So when y equal to 0, it will be x is equal to c1 over m, negative, isn't it? So these 2 points you can find and join the point to get the line. Now when you draw a line for this inequality, this straight line divides the entire space into three parts. Above the line is first part, below the line is another part, on the line is third part, on the line itself, isn't it? So here y is greater than this term. So y is greater than, so this is the area we are looking for. And the area we don't want is the down, isn't it? This part 2 area we don't want, since there is greater than or equal to. If this is less than or equal to, we will choose the second part of the area, not the first one. As far as there is equality in this given inequality, if there is equality, we have to draw a dark line, otherwise we will draw we will draw dotted lines. So this is the point to be remembered where we draw this kind of inequality. That's what I explained in this part1. You can check this one. Now some graphs have been given here. Y is equal to greater than mx plus b. So we have drawn a rough graph. Y equal to m greater than. This line says y is equal to mx plus b. Above the line, this part is y is greater than mx plus b. Below the line is second part, which is y is less than mx plus b, and the line itself is the third part. So every entire xy plane can be separated into three parts when we draw the straight line. So some examples have been given. Try this line. Y is equal to y is less than or equal to 5 minus 2x. Isn't it? When you take x equal to 0, the y intercept is 5. So this is 5. When you take y equal to 0, x intercept is 5 over 2. It will be here somewhere, isn't it? 5 over 2. So when you find x and y intercept, join them by a straight line. And now since y is less than or equal to this value, we don't want the area above. So we cross out the area above. We are looking for this area. So this is our solution space of this inequality, right? So in this way we can draw solution space for more than one inequalities and collect the convex region. That's our purpose. Convex region is bounded region by these lines. The solution set of all the inequalities together, right? So since there is equality here, we have drawn here a dark line. Otherwise this line would have been a dotted line. Now a solution to such kind of problems have been given. Actually I have given a link here in this description, so that some problems have been solved and you can use them to solve the other problems in the PowerPoint for this topic. I will come up with a new video for the next topic, which is linear programming problem, and it will be my own video. Thank you very much for your attention.